Let's see. Are we live? Hello, everyone. Hello, welcome to PROCEPTION Live, brought to you by Hackster and Avnet. My name is Robert Wolf, and you are in for a treat today. Today is April 24th. Gosh, time does fly. And we have a special guest in the green room right now waiting. If you're familiar with Kwabena Agyeman, he is the CEO and founder of a company called OpenMV. You may have seen him around the internet very much lately, as he just finished funding a Kickstarter for two of his amazing products that he's been working on for, almost a decade now. And I've known this guy for a long time. I'm just very thrilled to have him in this show today, because he's just fun. He's awesome. He's smart, and he's going to share a bunch of really cool stuff that's happened over the course of the time I've known him since this product came into existence. As always, for PROCEPTION, I'm going to be joined by my co-host, Tori Mochadam. He is also my business partner at Devico Consulting, here bringing you live this show on behalf of Avnet and Hackster. My name, Robert Wolf, Hackster Pro, proud Hackster Pro, and we have a lot of announcements that are going to come your way as well during this broadcast. Now, let's bring Tori onto the screen here. Tori, how are you doing today?
I'm doing well. How are you doing?
Doing great, thank you. Yeah, and I think since we did take a couple months off, I do want to brief the folks who might be watching this live and or on demand later. We like to kind of have fun during this broadcast. It's a little bit different take, as you might find during other tech broadcasts, where we're more, I think, on the entertaining side, right, Tori?
Yes, that's correct.
Funny. Try to be funny, try to make you laugh, and then most of the times probably just make you cringe sometimes.
Yeah.
All right, cool. So, Tori, we have questions for Kwabena. We have stuff to cover in terms of OpenMV, all the things that have gone on there. I want to take some time to get some announcements and take a sip of my Coke. We have some things coming up this next week, and I want to just kind of highlight those. We have a really, really awesome thing that I have been waiting a long time to do. Next week, Tori, we're going to have a Hackster disco party, and it's going to be in the newly refurbished Hackster Discord. But you didn't know that even existed yet, but we are going to know next week, Thursday at 11 a.m. Pacific. Did you even know about it, Tori?
I did not know the specifics. No.
Okay. Yeah. So we finally settled on the specifics. It's a whole party, and it's a whole agenda. We have awesome guests that are going to be showing up. We'll see if maybe Kwabena wants to join us. The whole slew of Hackster pros are going to be there. We'll have a stage. People are going to be coming in and out. Ginger, of course, the one and only from Hackster. She'll be there. She wants to actually do some disco dancing. Awesome. I will not be doing that, but we'll make her do it.
I will encourage everyone else to do so, though.
Yeah, absolutely. Okay, cool. So PROCEPTION Live, please stay here, stay for the next hour with us. I know you could go other places, but we want you to stay here with us and ask your questions. If you do enjoy this, make sure you hit the like button, subscribe to the Devico Discord. Subscribe to the Devico YouTube channel, because we will be doing these every single month. We're trying to do this every month on the last Thursday of every single month at this time. So we'll be bringing you guests. We'll be hopefully getting you up to speed as to what we will be covering every single month earlier in the month. So drop your questions. Comments are open, and let's bring Kwabena on.
Let's bring him on.
All right, Kwabena.
Howdy.
How's it going,
Hi, everybody? How are you guys doing today?
Doing all right.
Good. And you? How are you doing?
Doing pretty well. Feeling way less stressed. Finished doing our Kickstarter for the OpenMV N6 and AE3. We raised over $140,000, so it's our biggest Kickstarter ever. Definitely, these are a lot of work. It spent 2 solid months just promoting this, going out there, getting backers and such. And we have the late orders available, so if you still want to get on board the Kickstarter, you can. Once this closes, prices will probably be going up thanks to all the tariffs and other various things going on. But we're going to lock those in for right now and keep them at that point. So, if you want to take a look at it and back it, please do. Basically, we launched 2 new OpenMV cams. And so these are computer vision systems that run on a microcontroller. And what's really incredible about the OpenMV AE3 and N6, and so here's the AE3 for scale, by the way. This is
we gotta make his camera big. There you go. Let's show that.
Yeah, it literally is 1 inch by 1 inch, so the size of my eye. And so this little guy is a AI powerhouse. That chip in the center is only 7 by 6 millimeters, but it's able to basically run ML models like YOLO at 30 to 10 frames a second or so. And so it's basically the first microcontroller that's going to be able to, well, the other things have come out before, but this is going to be the first really usable microcontroller for a general audience that lets you run any model you want. So not just YOLO, but we're going to be able to do facial landmarks, human body pose, hand landmarks, as I said, YOLO, image segmentation, even instant segmentation, where you actually segment the image and then also detect the different instances of the segments. So all the different cool, computer vision algorithms that people want to use and put into real world applications, you'll be able to run that on board this tiny guy. And then we also have the OpenMV N6, which is our high-end OpenMV Cam. And so my camera's a little blurry here. Let me see if it focuses. Boop, boop, boop. Wish there was a button I could click to make it just focus instantly, but it's not going to.
It's all right though, because I mean you can kind of still see in terms of the size.
Yeah, it's a little bit bigger than the tiny one, but this is the OpenMV N6, and so this features the new STM32 N6 processor from ST, and this is a powerhouse MCU. The feature set is basically what the Raspberry Pi had back in the day, but with a AI accelerator on board. So it has something the Raspberry Pi does not. And so it has the ability to interface to MIPI CSI2 cameras, meaning that pretty much any modern camera sensor can be attached to it. But then it's also got the ability to do H.264 video encoding on board, meaning it can actually finally do high quality video compression like the Raspberry Pi did. Even has a GPU on board too, so you can do it can actually do 3D rotations of an image, rotate. Basically, imagine turning this picture into a rotating card with a background. So it can do that in hardware on board. So it's got the whole GPU image, and also has something called an image signal processor that actually will take in a raw Bayer image from a camera and then do the debayering on that up to 5 megapixels. And so that's the entire video pipeline that you basically had on the Raspberry Pi when it came out, what made it so awesome. And so that's now available on a microcontroller. But the key feature is that the STM32 N6 has an AI accelerator on board that offers about 600 billion operations per second to run AI models. And so it's about 3x faster than the OpenMV AE3 for this purpose.
Tori, I already talked a lot. Go ahead.
Yeah, so one of the crazy things that I love about this project is that you have MicroPython integration, and that seriously allows for people such as myself that don't have 1,000 hours to just try to do one thing. I think that's beautiful. What was part of your decision having MicroPython? Were there any pitfalls you had to go through? I just think that's awesome. I want to hear more about why.
Honestly, as we get to these higher end MCUs, the argument for staying in C becomes less and less and less. Okay, so literally yesterday, I was doing some verification work just to make sure our Ethernet interface on the N6 worked. The N6, by the way, has gigabit Ethernet on board. Again, gigabit Ethernet, ISP, H.264. It's a total replacement for a standard Linux SBC that does media video encoding, but way less power consumption, way easier to use with MicroPython. But I was verifying that. And the way that they did their embedded the code to actually control the Ethernet to run the examples from ST to get their Ethernet control working, they have a whole ThreadX library, something called NetX Duo, tons and tons of C code under the hood, doing all packet processing and all this other stuff. You have to integrate your own custom drivers for the PHYs that are on board. Luckily, the default PHY is what we use, so you don't have to worry about that for Ethernet interfacing. But just huge amount of C code that you're working with and that you have to play with to get this thing up and running. And the trick here is that, let's say you want to start adding a web server, right? Let's say you want to do a web server. Let's say you want to do an RTSP server. Let's say you want to do a request to the internet and such. All of that you have to write in C with mallocs, with min copies, with string concatenation, because when you're in the web, all of a sudden having the ability to do regex expressions, for example, and work with strings, very important, since HTTP is basically just a text interface where you're sending giant text, literally giant chunks of text files with new lines on them back and forth, and you're parsing those as they come back from the server as responses. And so I'm looking at the C code doing this, and I'm like, yeah, I mean, you can write it in C. You can totally do it. They did that, and they spent 10 files of C code to make a web server, and then you could write it in Python in 100 lines in one file, versus lots of mallocs and frees all over the place, and infinite risk for memory corruption around every corner basically. So it starts to, when you see things like that, you start to really realize what we're doing with MicroPython. Yeah. It totally makes sense for microcontrollers as we move up the stack and they become more interesting, more usable, when you're actually trying to do high-end things on them, like what a desktop computer would do. And in particular, for these high-end microcontrollers, you're no longer resource limited, really. Like the STM32, the OpenMV N6, it's got 64 megabytes of RAM on board that it's clocked at 800 megabytes a second. And so literally, like, if you look at the Windows XP min spec list, Windows XP can run at 32 megabytes of RAM, for example. So this thing, far outclasses really one of the computers of yesteryear, but in a small package.
We're looking at we're looking at the H7R2 or the H7 Plus right now. Which one are you talking about?
Look at the N6, just the N6. In terms of
you're talking about the M6. All right, okay, N6. There we go. Perfect.
Yeah, but also the OpenMV AE3. This little bad boy, there's 10 megabytes of RAM on this little chip in the center. Sorry, 13.5 megabytes actually. And then when you include the something called MRAM on board, it's more like 18 megabytes.
Wait, did I pass the A3? Where's that?
It's up top, the very top. Yeah, the A3 right there.
There.
Yeah, but the thing to realize with that is, with that much RAM on board, right, you actually have a heap now for microcontrollers that's on the order of 4 megabytes or something. And for microcontrollers, this is unheard of. Like usually you're dealing with like a couple hundred kilobytes.
Yeah.
And so just like you have the ability to allocate a megabyte object that could be the output of a ML algorithm. Like for example, if you run YOLO might give you a table that's 200-300 kilobytes for the output of the final tensor that represents the people that it detected in the image. And you can just trivially just malloc that now. But if you were still trying to do everything in C, life gets really complicated, generally challenging. And so, yeah, MicroPython is kind of like, it's a very sensible solution, we think, to dealing with these higher end MCUs where you start to have lots of resources available and you're really programming it like you want to program it like a desktop kind of.
Yeah.
You don't want to still be focused on, I'm trying to save every little byte of RAM and performance because there's no longer any need and you have the resources to really move faster now.
Well, especially when a lot of, machine learning, at least that I do, is in Python. Yes. So to then transfer to an embedded device using MicroPython, it's like the barrier to entry is almost like zero. It's kind of exciting as opposed to daunting. So I think that's a beautiful decision. And the crazy thing, which is my follow-up question, is that you have such low power consumption. That, I think the specs on that are impressive if you want to talk about the impetus behind why or how you drove that consumption so low.
Yeah, and we're okay. I'm going to add to Tori's real quick, right? So like the low power consumption, this is supposed to be inference at the furthest part away, right? Like, I mean, that's the whole point. Okay, if you could.
Yeah, well, let me talk a little bit more about that. Business perspective, okay? Here's what happens when people go to deploy computer vision systems in the real world. Right? Dollars and cents money matters, right? You can make the fastest, most fun, most powerful computer system ever, right? Spend all your budget on it. At the end of the day, when you talk to a customer, you're going to want to actually deploy quite a bit of those vision. You're going to put these things out there to the real world. You want to build a lot of them, right? And the cost that you're really pursuing for these vision systems, that's going to start to matter for you. The power consumption, basically implies physical constraints on where you deploy your system. So let's say you have an NVIDIA Orin system, which is costing you $1,000 plus for just the compute. And then you go off and buy high-end cameras. You want something that's ruggedized, could be outdoors, for example. You might spend another $1,000 on a camera module. That's great. You're getting the best performance. Things are running well. You have the best throughput. Awesome. but now your system needs to run on being plugged into a wall. Okay, so if it's got to be plugged into the wall, that means now you need to provide power for it. So this means that it needs to be either inside where electricity is available, but maybe there's not an outlet where you want to be. So then if you're actually deploying that system into some commercial setting where there's no outlet where you need to deploy it, all of a sudden you're looking at hiring a contractor to run conduit, to run electrical outlets for that. Maybe that looks like you're running PoE if you have a lower end system that can run off of PoE power versus the higher end Jetson. Whatever the case, you get into a situation though where you're basically installing custom switches, PoE injectors, all kinds of networking equipment. All of this starts to add cost to any deployment and installation. And so with microcontrollers, you have a new future where you can run off batteries. And this really changes the game for a lot of people. This is why we care about power consumption, because when you're running off batteries, this more or less means you can deploy one of these systems and it can be operational for months, if not years, on a large enough battery. The basic use case in do loop is that the system turns on, does whatever it's going to do, goes into low power mode, sleeps for a minute, 10 minutes, whatever, wakes up again, does something, goes back into low power mode, 10 minutes, a minute, whatever. And based on that frequency, then you integrate that over time, and then that's kind of like your average current draw, and then you can just times that, well, divide that by your battery life, and now you have an estimate on what your application life will be. And in some cases, though, for some of our customers, this actually ends up being years. And so what that'll look like, actually.
This guy right in his bedroom, he has like a full blown resistors of all ohms. And what do? You building stuff like before you go to bed, Kwabena? You just like building little circuit boards?
I mean, it's bedroom / office, so it is what it is. No, I have the whole thing there. Okay, 3D batteries, right?
Yeah.
These are 10,000 milliamp hours each, basically. You put 3 of them in series, you can get each one is about 1.8 volts or so, right, for a D battery, and they'll run down to about 0.6 volts. So you put 3 of these in series and you're going to get a little bit over 5 volts, right? And then that will run down to about 1.8 volts when they're all in series in operation. So with a buck boost regulator, you can ride 3D batteries from that voltage, that high voltage, down to the 1.8 and generate a 3.3 volt output the whole time. You use a buck boost regulator. But that'll let you then get, for something like the Arduino Nicola, and putting that into a deep sleep mode every 10 minutes, you're looking at an order of around 2 years battery life, for example. This is $3 of batteries. The battery holder for it is another $1. And that's actually something you can do for a commercial deployment then. And that's how you can actually make a real system that instruments, computer vision at the edge, basically, to automate some process and so on and so forth.
This is amazing, Kwabena. I mean, like, we kind of dove right into this, and I don't think we had a chance to talk about you as a person, as an entrepreneur, and as I want to say, like, a really resilient and just powering through over the years. But on this point, I did want to kind of like talk a little bit. I saw a meme the other day, and it was Sam Altman, talking about it was just a meme saying please and thank you to ChatGPT costs like I think millions or billions of dollars a year or something like something like that. So this is where these little subtleties can cost the world, right? A lot of money, but also, I mean, just a lot of impact on the environment overall. It's just waste, right? So I guess my question is, like, have you done any kind of calculations like that? Like, if this city were to replace every single one of their cameras with an OpenMV camera, we could save the world this. Like, that'd be a pretty interesting thing.
I feel like that'd be a job for someone to do some nice biz dev with. For me, it's more like, I mean, my head's just focused in trying to meet the needs of our customers and provide them the solutions they want. So we don't really have any time to think about those grandiose ideas per se. It's just like bugs are here to be fixed, things to put out. Trying to think about actually what the impact will be. Not quite sure, but the hope is it would be something useful like that. I do know what the impact can be for our technology, though, which is the hope is we can greatly help for America, for example. We can greatly help American industrialism with basically modernizing a lot of like equipment and things that were more or less created back in the 60s, 70s and such that the country still runs off of. You'd be surprised on how much industrial equipment is still a dial and a gauge that a person reads. And so being able to, basically strap a camera to that to digitize it. Then there's also using thermal cameras in very interesting situations, bringing heat sensing more to the edge so that you can, heat thermal cameras, for example. Let's say you want to measure the volume of liquid in a steel vessel, right? You can do that via a thermal camera because the air and water or whatever liquid gradient causes a temperature difference that you can see through a thermal camera through a steel vessel. And so now all of a sudden you can see how much material is inside something in an automotive plant or industrial plant or et cetera. And these problems waste a lot of energy, time, take things down, add lots of cost to people, add lots of cost to industrial systems. And so that's one thing we think about, which is as we help cameras get into these places that have no power, by the way, this is where the batteries are super helpful because there's no plug at all. And running one would not just be a simple, you can't just hire anybody to run conduit on a security clearance area, And so being able to put cameras in those facilities and such and really help industrial capacity, waste less time, be more efficient. Those are really, I think, useful goals that I want to help enable.
So I want to take a step back here real quick, right? Because someone might watch this and be like, I don't understand the flow here. I don't understand why having these cameras out there. We mentioned inferencing a second ago, right? We have AI. So I just want to kind of take a step back here and just like kind of run through this. Let's assume zero context. You're watching this right now and you're like, why the heck do I want this little camera that has zero power when I could just put this big camera? It's like, okay, well, I saved, but I could just plug right into the wall. Who cares, right? But the thing is that like the order of operations, at least now how we're seeing it, is that you have the extreme endpoint, right? The extreme endpoint requires a sensor to pop on or activate something, right? And then that trickles down the chain all the way up to the cloud, right? And so every point or intersection along this path activates more and more compute along the way, right? And so if you are capable of detecting the need for that amount of compute at the lowest energy point possible, then you don't need to trickle it all the way up the chain to consume the power of a cloud compute, right? And this is the whole point, is if you can inference at the furthest point, lowest power consumption, and say, no, that was just a dog. I don't need to turn on everything else to analyze that. This is, just so you know, people, this is why these things are so important, right? So OpenMV comes in, saves the day.
Yeah, no, it really is. Think about it like this, which is if your device just takes a picture and you want to get a picture to the cloud so you can run AI on that, you got to transmit that picture, which takes a lot of power. That has to be routed through a whole bunch of switches to then get to the cloud. Once it gets to the cloud, you got to run your algorithm on that. Typically, the picture that you just got was not the right picture, so you're then streaming pictures repeatedly until you get the right picture. It's kind of like a trail camera. Best way I would say it today, if you buy a trail camera and it doesn't have any AI on board, which is kind of the case, your SD card on the trail camera is filled with pictures of wind and trees rustling, basically. And it's like, great, I caught 1,000 images of my trees rustling. I didn't take a picture of the bear, though, that I wanted to catch a picture of. And it's because the trail camera has no intelligence, so it's just taking a picture of any motion. Versus it could now have AI on board where it'll actually detect, oh, okay, that's the animal or whatever we're looking for. Now I just have pictures of interest. And this, of course, matters for the battery life on that trail camera, for example. But then also, just imagine the use case when you open up the SD card and it has 100,000 images of wind rustling. How are you going to even find, the image that you're looking for, right?
Yeah, no, it's miserable. It's miserable. Tori, did you want to dive into anything on this one?
Yeah, well, one of the things I think is interesting is like, what are some of the things that you learned that actually led to the AE3 and the N6 along the way? I'm interested.
Well, actually, wait, real quick, Tori, this is a perfect question. Actually, so let's ask that question one more time. But I want to actually bring it back first. Okay, so do you mind, Kwabena, if I show that video of you 8 years ago and then we talk about after that.
You can go ahead and embarrass me.
Yeah, we're asking, by the way, everyone, right? So this is not the first camera, right, that you made. OpenMV and your cameras have gone through iterations. And I believe that the one that I'm about to show right now is the first one of your first ones, because you were just
pretty much back then we had just got done with when we first came out with OpenMV N4, that was the first one. And it was there were a lot of challenges back in the beginning of the company. Let me just say it like that. There were a lot of challenges.
I remember you showing this one. How come it's not? There we go. I remember you showing this one. Sorry, I tried pulling up the actual like raw video, but I remember I remember you showing this one, and you had your computer out too. Okay, and I'd like to also so this is Kwabena 7 years ago. Let me see. I actually put the date here. This was at 2:02 p.m. Pacific time. We were at the Hackaday Super Conference, and it was 31 seconds. What year? I put the year 2017, November 2017. Okay, me and Kwabena were both ARM innovators, and so like I don't think we had met. This was like one of the first times we hung out and met, but like we were hanging out during this conference. You pull this little freaking camera out of your pocket, and I'm like, holy crap, that's really cool. Then you plug it into, I think you start talking about an IDE. Like you took like an IDE and you made your own IDE, right?
Yeah.
So that people can program it. So let's watch this video real quick. And this is Kwabena 7 years ago. And it's pretty amazing. Ready? Can you hear the audio, by the way? Tell me.
It's a little laggy.
No, I can't hear the audio.
Oh, definitely I look a little bit younger. That's for sure. So that is the OpenMV M7. That's actually our second model. So, and that's the IDE software. Yeah, that was Hackaday Super Conference. I remember that. That was a really fun 2 days. I think it was 3 days actually.
It was. I think it was 3 days. Yeah, it was in Pasadena, and the Super Conference is pretty cool. I mean, it's like the way I see it, like that conference, like it was like really like grassroots developer. I was not prepared to, like, people pulling out their soldering irons and actually like doing stuff. So back to Tori's question, the path, right? This camera, you're a little baby CEO, right? By the way, I don't know if you noticed, like, Kwabena, he's been doing some workout now, but like, so now to where you are now, let's kind of walk through the steps here.
Yeah. So, I mean, OpenMV was a side hustle. And so if everyone who's doing side hustles, I encourage you, continue doing it. Hopefully you'll find customers, you'll start growing revenue, and you'll try to go full-time like me. I would say going full-time, though, has been challenging. Build up savings for serious, because it's going to take a couple of years before you start actually getting enough revenue to survive. So I'm slightly exiting the ramen phase now of full-time and getting to, I can pay all my bills and not burn savings, but it's still very challenging though. Bootstrapping right now, maybe potentially raise money, but maybe not. It's kind of like part of the point of building your own business and your own company is you want to have some control over your life and where you're going and such, and not end up with weird situations and exit terminations and other exit conditions that you have to meet and etc. Anyway, so we launched the OpenMV M4, got through our first Kickstarter to get that on board, and somehow managed to survive. All kinds of issues with that. We had 80% failure rate on the first production run of it. This is because we bought our camera chips off AliExpress, and they had been sitting around for years. So oxidization had happened, causing the pins on the camera IC to not function. So even though you soldered them, you didn't actually get a full electrical connection. So just, fun issues like that I never knew were a thing, like that you have to worry about the age of parts, that it actually matters how long a baggie's been opened. And all of a sudden you can't manufacture it reliably anymore. So those were fun experiences. But got the M7 out, that was selling, and that was our second gen. And then we upgraded to the H7 basically a year later. And we've kind of been on the H7 now for about basically till now. H7 and RT1062. And pretty much the next generation of microcontrollers is the N6 and the OpenMV AE3. And so these two systems represent a more than 100x performance increase from previous gen. The AE3 is about 200 times faster than our highest end RT1062 we launched last year. and the OpenMV N6 is about 500 times faster. How are they so much faster? It's not the CPU, it's the what is it? The MPU on board, the neural processing unit, which has that huge performance uplift because it's basically just a massive parallel array of adders and multipliers. So for the OpenMV AE3, that's 200 and I think it's like about 256 multiply and accumulate units in parallel, compared to 1 on the processor. So you have a very obvious speed up there.
Yeah, really cool. Yeah, so then inspiration, right? To Tori's question, what was your inspiration behind this?
Yeah, basically it's really OpenMV is my co-founder's idea, Ibrahim. And so it was started on Hackaday actually. So you can find the link to our original OpenMV Cam. Actually, go back to our website if you can bring it up.
Okay, let's see. Where is it? I don't know.
Go back to our website on the About page. Actually.
Okay, here. Okay, About.
Yep. You're not sharing though.
Oh shoot, my bad. Right here. This is the original.
There's a blog. There's a blog post. That's the original. That's the OpenMV Cam. That was the OpenMV Cam.
It's not even red. It's not even
red.
Not
even red. And so that's the original. And that one right there is the OpenMV 1. So that's the first OpenMV Cam that came out. The version 1 never really got produced. And so Ibrahim built this back in 2013. And I actually got started and involved in this because I was bored working at Oracle Corporation. And I was looking for something to do, and Hackaday was the thing at that time. And so I went and checked out Hackaday, and I ran into the project with the most stars on Hackaday at the time, which was OpenMV. And I was like, oh, this guy's doing computer vision cameras. This is cool. Let me email him. And so I emailed Ibrahim, and we've been working together ever since.
if I email you now, I can start working with you?
Yes. I just need to get more money.
Yeah, no, we were super excited, by the way. Like, I mean, this is an awesome story. When I was sitting on a call with Tori, right? And I was like, oh, by the way, I noticed that Kwabena's campaign is almost up over on the Kickstarter campaign. We haven't even pulled this up yet, kind of. But we noticed that the campaign was almost up. And I was like, Tori, like, we gotta back this, man. Like, I want to play with one of these. You know, like I just posted the LinkedIn thing about the first one, and so we both, of course, backed you, right?
Thank you. Thank you so much.
It's such an amazing project, and plus the MicroPython again, because so many things are out of reach for someone like me. I'm a hobbyist. I have some of my side things as well. So this actually makes it fun. And so I really appreciate the time and dedication that went into actually making it so MicroPython could work on this. And I think that's phenomenal.
So I want to talk about, oh, sorry, go ahead.
No, yeah, go ahead.
I want to talk about supply chain. I want to talk about the developer journey here, right? Because now we've talked about, the OpenMV 7 years ago, your discovery of a cool thing that you wanted to get involved in, and then its evolution all the way to where it is now. Not everyone has that experience, okay? And, when you're working with so many different partners, I'll pull this up right now. We're talking about this in the green room, where you're working with so many different components, so many different partners, so many different software pieces, and you have to get all of these things to function together in time before that thing goes end of life so that you still have time to sell it. Supply chains can be difficult. And not only that, working with chip manufacturers can be difficult. So what we call this in business is we call it the funnel, right? Now, at what point, and we were talking about something on the first PROCEPTION with Trevor Kane, is that developers maybe have an idea, right? And then they say, okay, well, I'm going to go join this community, Hackster, and I'm going to start seeing what my idea, if it takes get some legs. And then all of a sudden people start to like it, and they're like, oh, well, maybe my idea is pretty good, right? They actually start to source it. They start to get the supply chain somewhat in order. They're going to Avnet, they're piecing this together. They're going over to somewhere else, piecing this together. Now, at what point does someone come in and say, ooh, Kwabena, you're onto something here. I want to help you. I want to put my resources into you because I think that you might get somewhere, as in from a company standpoint.
They don't actually do that. It's what you do is you go around begging people. So that's how it works.
Okay.
It's very much though about your own hustle and ability to network, and then also just emailing folks and trying to be aggressive at reaching out. So there's no inbound leads on, hey, can you use our device or anything like that. That doesn't actually happen. But at the same time, also, you really wouldn't want those. Like when you get those inbound leads, generally it's a waste of time because that person's trying to do sales for something that no one wants.
Yeah.
So typically what ends up happening actually is you meet people in person, like how I met you, Robert. You meet people in your community, in your network, you talk to folks, and just like a lot of it's just businesses, you got to be on the ground in the game, going to the events, meeting people. Like that's one of the first things people to notice that you exist is to actually be going to these things. So when their Hackaday Super Conference is happening, or there's a Hackster event or Edge Impulse or any of these other companies, being there in the room to meet people in person is actually kind of required if you want to go out and do something and source and build relationships and such.
I think this is the reason for programs like Hackster Pro, right? Like this is the reason for programs like that early ARM Innovator program, right? You get exposed to people, you get exposed to things, and that in my opinion, Kwabena, that needs to change, right? Like, I mean, you're already working your darn butt off, right? Like you don't to go out and have to be rejected nonstop. It's like at some point, companies should take some responsibility to identifying the key players in their industry. And I think that's why programs like this are extremely valuable, right? They're out there, Ginger, she's out there actively searching for people who are doing amazing things. And this now enables them to identify the key players like yourself. So I want to say that, if you had a program like this, even ARM Innovator program, I mean, like that had to be an enabler for you because we would not have met.
Oh no, it was, and I think I'm not sure how that happened. I think I applied to it though. They didn't necessarily reach out. Maybe
the ARM Innovator program.
Yeah, I actually do not remember. It's been such a long time.
That's on them. They have to promote their program a bit, right? But
yeah,
now you found the good people. You put them in the same room together and see what kind of magic happens.
Yeah, I mean, it really is just about there's not so many people actually really devoting themselves and working hard on these things and staying in the game. And so, I mean, that's just really what it ends up being. It's entrepreneurship in general. It always kind of, it looks, for any industry, it looks similar, I suppose, where you have to go to the events network and meet people in the game and see who's doing what. But that's how it kind of comes down to that. But then if you're doing that, that's where opportunities emerge. All of a sudden, you can ask people, hey, can I get access to the sensor? They'll give you help and support. An example being like for both of our OpenMV AE3 and N6, we have a great relationship now with a company called PixArt Imaging. And so PixArt makes we're using their global shutter camera as the default sensor for the OpenMV AE3 and N6. And so this is a 1 megapixel global shutter that can run up to 120 frames a second at full res and 240 FPS at VGA resolution. So very, very high performance for machine vision, which is the point of our cameras. Not just like taking nice images, but then also we have a 30 FPS HDR image sensor that, for example, you see my windows out here, they're blown out, you can't see anything. The HDR sensor can see right through that and they don't blow out. It doesn't have any problem. But, both of those two sensors, though, PixArt normally isn't interested or, doesn't even care about necessarily courting the hobbyist industry, but they believed in us and they liked what we were doing with TinyML. When that used to be called that before it became the Edge AI Foundation.
Edge AI Foundation, yeah.
And so met them through that conference, and from their support and from talking to them over the years and working out a relationship, they're giving us access to their image sensors, which have a very good price on them and very, very good performance. And we're actually able to get data sheet help, like we can email their employees and actually get like guidance, tips, and pointers on how to fix things. For the longest, we were using OmniVision sensors, which is, there's a leaked data sheet online and random drivers people have written, and that's how you get the camera working. You can never email OmniVision for any help support whatsoever. So these are the things that, have made us successful, is that we met, companies in the real world and slowly over time got taken seriously that we were in this game for a long time and moving and shaking, and then we're able to level up our game after developing those relationships.
Tori, I gotta leave some dead air every now and then, right? Like, so someone can speak up.
Well, one of the things, I have a kind of a fun question. When are we going to see OpenMV device in space? That's one of the things that I was thinking about. I was just like, you could find, do some navigation stuff with this. but do you think that's in the cards?
In space?
Yeah.
Well, MicroPython already has some stuff in space, and we get emails from different students doing stuff in space every now and then. So I think actually probably OpenMV Cam most likely went to orbit already. We've sold over 100,000 in the world.
Wow.
That's what kind of orbit? It might have just been the up and down one.
Okay, yeah.
Well, that's not orbit. That's going into space, but it's not, achieving the
Yeah.
velocity to escape and actually go out of orbit.
Geostationary orbit or something like that, I guess. But yeah.
No, I don't know. I don't see any time soon. But look, we never know. As you make things easier, you can get put into all kinds of systems. I would say, seeing OpenMV cams appearing in industrial plants has been one of my biggest joys. Seeing them being put to real use cases and such, and so that's been very cool.
Yeah, I want to say like community, right? Community is a big thing, and looking here on your website, once again, I don't know, Tor, if you could pull that up.
You want to go to the partners program or
the what?
The partners page or so?
Oh, we can go back to there. Community. This makes me think of one thing, right? Like, because I remember back in the '96 boards days, all these boards that I have here behind me. We stumbled across a little open source project called Pinout XYZ. If anyone,
yes,
using this, Kwabena?
Yes, you showed it to me.
Yeah. So this, then I look at your diagrams here, and I say like, hey, I'm giving a talk tomorrow. I'm on a panel. Okay. Industry insights for UCSD, University of California, San Diego, for undergraduate student council, right? We're trying to kind of like bridge the gap between industry and academia. Then I have another talk on May 15th with another student org at UCSD about internships, and don't freak out, you didn't get an internship. And then I think like there's a little gap here. And students are out there trying to get internships when they could be also doing cool community projects like this for awesome products and things that people use, like the OpenMV. And I just ask you a question here right now, like if we were to put this onto a short starting right now, Kwabena, if you wanted to get something like this turned into something like this from your kind of printout schematic to this, dynamic, awesome, interactable schematic, you can go fork pinout.xyz and then turn it into an OpenMV version of this. Is this something like you'd want the community to go do for you? Like, is this kind of like community projects?
No, we'd love to see this. Honestly, MicroPython needs more folks contributing to the community. A lot of folks do a lot of great work putting out. Actually, what's nice about MicroPython and being plugged into that is that pretty much a Python library for almost everything you thought of has been made. Like we had a customer, for example, reach out to us in the forums, and they were like, hey, I want to do FTP uploads of images to the cloud. And I'm thinking to myself, okay, that's not the right way to do it, but you're supposed to use uRequest and multi-part file uploads to do that. But they wanted to use FTP, but I did a little quick search, FTP, MicroPython, someone had made up a library. And then I asked ChatGPT, how do I send a bytes image, a bytes object to the FTP library? And ChatGPT was like, here's the code. And I was like, boom, here's your question answered on the forums. At the same time, that person should have done what I did instead of asking me on the forums. Like they should realize ChatGPT plus Google search would answer the problem.
1 in 100, 1 in 100. This is like going to a student hackathon, and I used to do a bunch of student hackathons, and like my answer to 9 out of 10 questions was, oh, let me Google that for you real quick. This link right here, the first one that showed up, like that, I don't even say, did you Google that yet? It's just like, I just like say, oh yeah, let me answer that for you real quick. What was the question again? Enter. There you go. It's like, cool. ChatGPT. People like, I mean, ChatGPT, just AI in general, GPTs in general. It is pretty cool. And
yeah, but the community's been doing a good job creating MicroPython libraries. Honestly, as we get, I think what we need more help with really is there's some gaps in like the MicroPython machine library. So more commits and people who could like really help flesh out the implementations for every microcontroller would be useful. There's too much work on me and Ibrahim's plate to do everything. So we typically just focus on the biggest fires first. That usually is paying customers. And note, buying one camera does not make you like a very paying customer. Paying customers have contracts. That's what I have. That's how I survive and don't run out of money. I have to actually, because the hardware does not have huge margins on it. We're trying to make things affordable. But I mean, like, so what we do, basically helping to build out more features in this into the machine module, so more people can do stuff. That's been very helpful. A lot of work has gone into the ESP32, for example, but MicroPython gets all sorts of support and commits and things. And so all of these really help, build the community for what people are able to do. Like an example being, hey, if we don't have perfect PWM output and there's some features you want, send a PR and help MicroPython out and make the code better. There's all different types of features and pull requests going in there. Crap. Yeah. But here's the trick. A lot of folks will send a pull request and then like they get asked to change something and then they just don't.
Yeah. Peace out.
Yeah.
I did my job. You fixed my mistakes. I got you 50% of the way. No.
Yeah. And then it never gets merged. It never gets merged. So this is actually a good opportunity to learn how pull requests work because basically when you're trying to submit a PR here, first people are going to be like, why do I need this? Second, you have to fight for your pull request. You have to keep asking, hey, did anyone get a chance to review it or you make the changes? It still takes a very long time to get some things in there. But, when the community helps send these, everyone can use this kind of stuff. You see, for example, the work in progress right there. That's the N6 PR. We're helping to pay for that. And so that's us. Damien right now is working with us to get the N6 port done and put into MicroPython for everyone to use.
Wait, where do I see work in progress? I don't see that. Where?
Right there, the second link.
Oh, there, yeah.
Oh, yeah. Okay, work in progress.
Yeah. And so that's OpenMV actually helping to get that put into place. And this is something that literally everyone's going to be able to use. This is 100% MIT source code. And then we also merged the Aleph port. Like, for example, if you go up, you want to see a massive PR, how much work it was to support Aleph, go to closed PRs.
6,000.
Go to closed PRs and scroll down. Oh, wait, no, you won't be able to find it because it's wait, actually search for Aleph. Closed is closed and search for @Aleph. Let's see if that. No, you want to keep the is closed.
Oh, my bad.
And then say Aleph. Yeah. Okay. Add new port to Aleph MCUs. Check out this massive PR. So this was a year and a half of work. Commit 77.
10,000 lines. 10,000 lines.
10,000 lines. If you scroll down, you'll see the number of commits, and that's squashed. It was actually 200 plus commits before we squashed it down into a lesser number. But this is the Aleph ensemble port. And so both Damien and Ibrahim spent a year and a half working on getting this functional. Just the amount of work and pain and suffering to get through it, incredible. But now this is a huge value for everyone in the community. Everyone is able to use this port and build a product on the Aleph chip, for example. Including. Note that this does not include, though, the AI acceleration part. This is just basically turning the microcontroller, just making it usable with MicroPython. So, to actually make it as good as OpenMV AE3, a lot more work ahead of you. But at minimum, though, this gives you something, a base layer to the work that can actually toggle I/O pins and such.
So this right here is just a perfect example, right? And it's kind of interesting. It actually became very, very evident to me later on, though I didn't realize it early in my career, that open source developers, engineers, right? Like you build clout by doing things like this. And then when I go in later on, I thought, oh, well, the barrier to entry to getting, into one of these, types of projects is so high, but it's like, yeah, because you have no reputation. You haven't had any pull requests merged into open source, projects. You didn't go out there, right? And like that's the thing, right? Is that this is just as good as industry experience. You're going through the ringer. You're putting things out there, and it's all version control logged, right? You're meeting people. When I can go to a client or a friend or a community member that needs help, and I can say, oh yeah, no, I know an engineer who has clout in the open source space. They get their pull requests merged. That's a big deal, right? Like because you just know. Yeah.
No, it's all over the place. Like TensorFlow Lite for micros, MicroPython. We leverage that. There's a ton of different open source software libraries that we use to build the OpenMV firmware. I mean, even our own firmware, for example, if you like an OpenMV send a PR for a feature. That's what we really need. Folks are asking me and Ibrahim to fix every bug, and we try as we have time allowance, but we always have to focus on kind of what keeps the business afloat. And so, whatever help we can get on documentation or PRs, we really like and appreciate all of that. I mean, one of the things we have decided to do is actually make our stuff public so that you can do that. For example, one of the weird things that we do in OpenMV, not weird, but like interesting things that you may not see on any other commercial company is if you go to our web, go to our homepage, if you go to our products.
I am there. I'm at products.
Okay, go to products. Go click on the OpenMV Cam H7 Plus, for example. No, actually RT1062. Click on the RT1062. Okay, now if you scroll down,
fancy
videos and such. No, scroll down. Okay, you'll see the camera board design, rendering PCB. Okay, so click on the schematic there. Okay, click on a wire. Click on like the USB bus trace.
Ooh, okay.
Just click on any trace. Okay, now click on 3D on the right-hand side of it. That little 3D option. The right-hand side. Yeah, okay.
Oh, I see it. I see it.
See the trace, and you can zoom in on it. Yeah.
No freaking way. How do you do this, man? Where do I get this? How can I do this with my stuff?
This is Altium. So when you have your file in Altium, you can upload your files to a personal Altium cloud, and then you can embed them into web pages so people can see what your stuff is doing. So like we're the only company I know of right now that is making publicly available every single board design we've ever done. Now you can't download the board designs. We stopped allowing that, but this is basically everything you need. Like from a viewing perspective, there's no reason you need to download my files unless you're trying to like copy our stuff and then sell it and make money off of our ideas. So we're trying not to allow that no more. But for any of the engineers who actually want to like use our stuff and figure out what the heck is going on, we literally give you every single wire. Like you want to know where a wire is, what it's going on, exactly what's happening. You have that. PCB view, you can see the copper traces and copper pores, 3D rotations. I mean, it's amazing. And so, this is our kind of commitment to being open with OpenMV in our name, which is we want to make engineers' lives easier. So open source software, but also open source, well, not say, open source isn't necessarily the word, it's like source available, I guess. But it's made to basically make engineers' lives easier because my kind of top perspective there and what I care about, all the parts are linked too. So if you want to figure out where the parts are and such, that's not the real cost of the board though. It's underestimating it greatly. But the idea though is that you get some, it costs more than that. It's making up some numbers there. But still, we give you access to all this stuff. And because my purpose of my goal here is I want you to actually, like the engineers, to be able to figure out how something works inside and be able to debug. Because from my perspective, what I hated the most when working in a professional company and working with other companies is that their stuff would be broken in various ways. And when you would find out that the stuff was broken in various ways, you had to wait on help support from the company. You couldn't do anything about it. Like, because we have our hardware design open, like if you're decent with the soldering iron or any tools and you find a bug you don't like, you can just go in there. Okay, I see where the wire is on the trace. Let me just, do all the changes I need. Boom, unblocked. I don't have to go back and forth over a month trying to get help support and fixes. Same thing for all the firmware. If you find a bug, you can get the JTagger out, go in there and debug and figure out whatever you want. All of this is designed to kind of make the engineers' lives easier, so that you don't have to find us being inserted in the critical path every time you get into a problem.
That's really cool. Tori, I got a few more. I got like closing this out in a second, but let's get some last thoughts out for you, Tori.
Yeah, what does the future look like for OpenMV? Where you go from here?
What does the future look like? Basically, really, we're focused on just upgrading the product quality and getting it out there. I mean, shipping the OpenMV Cam AE3 and N6 is the biggest, most immediate goal. We have other features like LTE support that we plan to offer in the future. And so this would be like an LTE shield for your OpenMV Cam N6. So once you add that, now the bad boy has Wi-Fi, Bluetooth, LTE, and GPS antennas on board, along with the low power ability. Now you're talking about a camera you can deploy anywhere in the world and basically run off the grid and take high quality pictures. A lot of it's about also just upgrading our sensors and portfolio. So There's new distance sensors coming online that can do, almost like VGA resolution distance sensing. So adding support for things like that. We're also looking into dual camera options. So we're, on our website right now, we're going to be launching 2 new cameras, which is our
stereo vision.
No, not stereo vision. That's not interesting for our customers. Check it out here. This is a FLIR Lepton and
Wait, let me bigger.
This is a FLIR Lepton and an OV5640, and then this is a FLIR Lepton and our PAG 7936, our global 1 megapixel global shutter. But the idea is that these, setting up dual camera pipes where you can do thermal plus vision at once. Maybe in the future, vision plus event camera at the same time. The idea, though, in general, is just start to do new and interesting things people aren't doing, kind of giving you that multimodal imaging and then combining that with the ML, so that you have the ability to, because this is where you start getting like interesting problems. Like if you can see the temperature of something and the video and the regular the regular color vision of it, and then you can run both of those images into an ML model. Now you can have like really interesting inferencing going on. For whatever kind of system you're doing, because like thermal data, the cheap thermal cameras, they only do like 9 hertz, not very fast. But then if you combine that with a fast rolling shutter camera, maybe you can have a model that like takes in thermal data at a low frequency, low res, and then mixes that with the fast moving color data to basically create something that generates fast, high speed thermal from like a high speed thermal vision output, but from a cheap thermal camera, for example.
Oh, that's awesome.
Future.
For customers, someone has to figure that out smarter than me. I'm not going to do that ML model, but we'll make the hardware available, basically.
Right. Did that answer your question, Tori? I mean, like sometimes you ask someone like what the future is, like one thing. And that's a pretty bright future there.
It's making my wheels turn right now, right? I got to figure out how many of these I have to buy now.
Well, we're just trying to do stuff that people aren't doing. I mean, I kind of added those, this also like throwing everything at the wall to see what sticks. That's what startups do. So, that's in general kind of what we have to be in right now. But it's the goal, though, is just try to explore these interesting novel concepts and then also make the electronics just better. Like as I'm getting more reps now at just building the chip boards and such and knowing what chips to choose, we're really improving the quality of our circuits. Definitely a huge way since we started doing this back in 2013, like much better electronics now.
Kwabena, thank you so much. But you know what else startups do? I'll tell you something. You know what startups do? Startups go and hang out with us in the Hackster Discord server. And I think that's a really cool thing. It would be really awesome to have you next week hanging out with us at the Hackster Discord launch party. And I'll tell you something. I will promise you that I will try my hardest to rally some community members around the stuff you're doing, and your time in there will definitely be worth it. Even your 10 minutes hanging out with some community members, I'm sure could turn into some of these, like cool community things you're talking about right now.
Well, I don't mind doing an AMA or something like that. I can't be on it the whole time.
No, you don't have to.
I already got enough messages and email.
I'll safeguard you. I'll safeguard you from the paparazzi. You don't worry about that.
Okay.
Yeah. Okay. So if I email you the link to the actually, let's just talk about this. This is the Discord server, right? So like you don't have to join right now, Kwabena, but it would be cool to have you in there. You are a Hackster Pro?
I think maybe, I don't know.
If not, we can talk about it. But like get you in there and like it'd be cool to kind of like get you on a casual AMA here and there, and it doesn't need to. We're going to be doing monthly office hours. Ginger's going to do a really cool. I believe it's I forgot hang out and nerd out. I think she used to do the pretty cool podcast with Alex and David Groom. But yeah, there's going to be lots of cool stuff happening there. Tap in every now and then, and I think that the community members really would love to kind of like contribute to something like this, because you have so many cool things to contribute to. A lot of companies don't.
Thank you.
Yeah. So that's the Discord server. I want to toss this up one more time. OpenMV.io. It's a really cool site. There's lots of cool things to check out there. They have products, links you over to their Kickstarter, lots of videos, high quality, high production videos, lots of information, resources, documents. And I think that you can spend the day there. Spend the day there like Disneyland, exploring the OpenMV ecosystem. And Kwabena, before I kind of give the actual final remarks, would you like to give any other plugs?
Other plugs. Robert, thanks for all that you're doing. I love it. Thanks for being a friend. This has been an amazing time. I also wanted to say you'll find me next month. I'll be doing a keynote with the Embedded Online conference, where I'll be talking about some of the under the hood features of OpenMV MicroPython and microcontrollers and where we're going, kind of expanding on that topic about MicroPython being future, I think. And then I'll also be at the Embedded Vision conference in person with a whole booth and everything. I'll be showing off the cameras, running AI models, and so on and so forth. And those both are in May, about 10 days apart. So I'm a busy man. I've got to
wait. Did I get that?
I've got to do a lot of work to prepare all this stuff. Yeah.
The Embedded Online conference. Did I get that right?
Yeah, you got the Embedded Online, and then also the Embedded Vision conference.
Oh, you're going to be up there. I remember seeing you there a couple of years ago. That's in like San Mateo. It's in San Mateo.
Yeah, it's in Santa Clara. So I'll be there.
Santa Clara. That was a really fun event.
No, it's going to be good. Folks need to come up with a better word than embedded. That's way too. It's basically there's too many embedded something now.
Yes. You know what, Tori? That's something we should brainstorm.
Yeah.
In the Embedded Vision Summit was a lot of fun, by the way. All the Hackster folks were there, as cool seeing Jessica and Ginger, and we hung out a lot over there. And you, Kwabena, we actually saw you too at Edge Impulse.
Yeah, I had a booth last year, and I'll have a booth this year. So hopefully be able to keep going to it every year and just bigger and better every year. Love to have I ran by the conference organizers and I said, hey, can we do like an ice luge at the event? And they were like, yes, you could, but no alcohol on the site, and you'd have to pay the event venue to do the ice luge. Even though you have the most fun booth possible, if you're just giving out drinks, everyone would be drunk around you, but that would ruin the
ice luge. Okay, now I'm sorry. By the way, everyone, the show did end like a few minutes ago, but I don't feel bad. I want to ask you this. When I was younger, obviously party animal, 20s, late teens, ice luges were disgusting. Like, are you talking about the ice luge I'm thinking about? Because everyone's putting their mouth on the.
No. So yes, but did you go to the NVIDIA GTC conference?
Okay, let's see. There's a new ice luge. There's a COVID post.
No. Literally, so if you go to NVIDIA GTC conference, the NVIDIA more or less they made giant ice sculptures.
Gotcha.
And they would have different bar setups throughout the venue. And so they literally poured alcohol. They had someone pouring alcohol into a ice sculpture. And then they would serve you a cup at the base of the ice sculpture. So people didn't put their mouths on it.
Oh, a cup. You just put the cup at the bottom. Okay.
Yeah, you put the cup at the bottom. But they had someone on staff just doing ice luges there. And I thought this was the most over-the-top conference I've ever seen. Like literally, they don't have any pictures of it publicly, but that was totally what was going on. There was just there were like ice sculptures every 10 feet. And they had a person on staff just pouring alcohol into the ice sculpture and just giving you. And I was like, this is wild. Like I got to see the governor rolled through NVIDIA GTC, and I'm like, man, everyone's here. Like NVIDIA, Jen Hudson Jen's son was walking through with a gold pen, just signing people's stuff.
Oh, he was.
He up their shirts, and they're like, he's just signing. It was an amazing conference.
That guy got famous. I feel like out of nowhere, right? I mean, don't get me wrong. He was known, but all of a sudden, it's like he's the guy who gives conferences and talks in his kitchen, and he always has GPUs sitting behind him, and then he wears his leather jacket, and you're like, holy crap, he's everywhere.
Yeah.
All of a sudden, yeah. But very cool. Okay, Kwabena, back at you, man. It's been a pleasure being your friend,
yes.
And looking back over the years, Tori, brother, I want to thank you, man. This has been good.
This is fun. Great conversation.
Cool.
Love to nerd out. This is great.
Awesome.
Thank you.
Yeah, we're gonna close out now. Thank you so much. Last mention here. Make sure you go check out Hackster right here. Hackster.io. Oh, sorry, wrong one. Hackster.io. Hackster.io. Check them out. Sign up. Meet us in Discord next week. We'll be doing a launch party. Discord.gg/Hackster.io. Kwabena said he might be there, and we'll have some fun. Take care, everyone. PROCEPTION Live. It has been a pleasure seeing you all here. We'll see you next month. Thank you.